After your grading, you can really ask you questions with each one.
I mean, it shouldn't really change anything. I mean, I would still just tell you whether or not, like, oh no, that's something you need to consult back to previous materials, like you already have that answer. Or, you know, if it's a question about, like, I don't understand what this question is asking, or, you know, what this is supposed to be doing, then, you know, I'll let you know if I can. Also, I think that what I'm going to do, as far as the exam goes, is make like a short, probably less than 5-minute video that talks it, like, that goes over the code book for the data sets that we're using, to kind of explain what the data sets are. Because the data sets that we're using are actual data sets from one of my studies, and it's just going to be the raw Qualtrics file. And so, you know, all of the extra crap that Qualtrics exports will be in those data sets. And so, like, I plan on writing the instructions to kind of walk you through, like, what it is that we're looking for, because there's a lot of variables that are just going to be like, just completely ignore all this stuff. But at least as far as the variables that you will be working with, like, I'll explain through kind of what these different things are. And you'll have the code book that's just an Excel file with all the variable names and, like, what the specific questions we're asking. And then probably I'll also just upload the actual Qualtrics, where you can export your survey to Word, so that you can have the full survey, as well as, like, the way responses are coded, all that sort of stuff. That way, like, you have all the information you could possibly need as far as understanding, you know, what all of these variables are, how they're coded, what the value should be, et cetera, et cetera. And yeah, so that said, we can go ahead and get started on today's. Here at the beginning, I'm going to walk you through a couple things that we haven't explicitly discussed. It's things that we've used, but we haven't really talked about. And then after that, there, like, down at the bottom, there's just an activity that y'all can work through some different types of cleanup type stuff. And so for this one, like, you don't really even need to know what all these things are, but, like, I can explain as we go through as we need. But for now, just suffice to say that we load in these two, there's 2 time points on this. The pre-data is data from the SONA pre-screener, because this, again, is real data of one of my studies. So the pre-data is the pre-screen from SONA, and then post-data is the Qualtrics. No, it wasn't Qualtrics. This one was done on Media Lab. But anyway, the pre-screen and the actual study data. Yeah. So just like when you're, anytime you're using select, if you list a column and then a colon and another column, that tells select, I want all of the variables in this range, just like saying, you know, 2:10 will return 2 through 10. All right, so one thing I want to talk about is join, and we've used this before, but I want to actually talk a little bit about it, because this is something that y'all should know, or at least have in the back of your mind to know what some of these things mean. So whenever you're joining together data sets, you'll just join is at least one function that can do it. The specific things that I want to point out are the arguments by, type, and match. So by will tell Plier what variable you want to join these 2 data sets together. You have, you know, time 1, time 2, like, what variable do we want to use to link those 2 things together? Now, in this case, you'll notice that I don't have any of those 3 things. I literally just had, like, the 2 data sets, and that's because I had to anonymize all the data sets and stuff like that. And so at first I was going to give both the raw file and say, here is, like, the full spiel of how you would actually connect all this. But then I realized, like, oh, wait, you know, this has student names, student IDs, emails, etc. And so I had to anonymize it and then go ahead and filter down to all the right people and blah, blah, blah. But let's just say that we did have other things. If you if you leave out by, it will by default join by any matching column names. So if you have, well, first of all, you just shouldn't have, the same column names in the two data sets. My convention, whenever I have like a pre, post, or time 1, time 2, time 3, that sort of thing, I name all of my variables in the pre-screen data or the time 1 data. I just do like a lowercase p dot whatever the variable name is. And then the time 2 data set is just the variable name. But that's how I know that, like, oh, this p is the pre-screen, or is like the time 1, or I'll name it like time t1 dot whatever, t2 dot whatever, t3 dot whatever. So that's my personal convention. But so if there is only one variable that has a matching name, in our case, in this one, it is, sub ID is the only common variable between those two data sets. So by default, it connects them. It will find matching sub IDs and put like both of them together in one row. So that's how you can specify which variable you're wanting to link them together. Match just has to do with if there are duplicate identifiers, like does it match the first matching row. So if it's working down and it finds sub ID 5, it matches that with 5 from this one over here, and then down here if there's another sub ID 5, it just ignores it. So if you have duplicates, that's what this is all about. Or all means that it'll match all of the things. But the type is the one thing that I really wanted to point out today. So there are different types of joins. There's left, right, inner, and full, and at least in R. And so what this is talking about is, let's say we have 500 participants that come in and fill a survey. And then we invite them back to come back for a second time. It would blow my mind if you ever get a 100% retention rate. Like, you may only have 300 participants in the second. So when you join these, what does that look like on the back end? Well, that depends on what type you have. So do you want to keep all 500 of time 1 and then just add on for these 300 who did time 2, where they have time 1 and time 2, but it still has the other 200 that didn't do time 2? That would be left, I believe. Yes. So if the type is left, that's what it's saying. Like X and Y, we'll say X is the time 1 data set, Y is the time 2, so it's left, and right is X and Y. And so if your type is left, then it's going to give you all of the rows in the first data set plus all of the matching rows from the second data set. A right join is the opposite. It'll give you all of the rows in the second data set plus any in the first data set that match. In our case, what we're doing by default is an inner join, which is only return rows that have matching IDs. And then full will basically do it both ways. That if you have some people who did the second survey that didn't do the first, they'll be included and they'll just be blank for the first survey. If you have people that did the first and not the second, they'll be in there and it'll just be blank for the second, plus it'll match those that can be matched. So an inner will keep all the data and just match it where, or excuse me, a full will keep all the data and just match it where it can. Inner will only keep the places that has a match. Left will keep all the data from the first data set plus matching data in the second, and right will keep all of the second data set plus any that match out of the first. So
hypothetically, like inner and right would do the same thing.
It's possible, but not necessary, because like in this case, if the only people who did time 1 are invited back for time 2, and there's no possible way that anyone is in time 2 that's not in time 1, then yes, inner and right would do the same thing. But that also is dependent on, well, did somebody have a typo that they were putting in their student ID and they mistyped something? And so now there's a participant in the second data set that doesn't have a match on the first one, which really is just because of, that typo. Which when you're doing cleanup, one of the things that you have to do whenever you're joining stuff like this is pay attention to the number of observations that are being output. And so you may start, like what I'll usually do is start with like a left join so that I can join things and then look, and I'll just scroll down to see where like time 2 stops or where, like the time 2 data stops, and see like, oh, these rows down here don't have time 2 data, and should any of them, and then kind of from there figuring out, or rather, if you're doing a full join, looking and seeing who has time 2 but not time 1, and identify those select cases, and then figure out, okay, why didn't these match with these other things? Which is something I deal with a lot. Mostly because when you're linking through Sona with the pre-screens system that we use, it can be kind of a nightmare as far as like linking together that login ID with your data on the back end, and you're almost always going to have some sort of typos, and so you'll have to go back in and like manually correct the login ID from one of the data sets, and now everything will match and play nice. But yeah, like data cleaning is, when I was talking about, this is something that you could spend weeks really covering. Like it really is something that you just have to sit down and work through. And in fact, when I first started really doing a lot of data work, like I would often use Excel in conjunction with R, because it was a little easier and more intuitive. I'd be able to very quickly go and like sort columns and by ascending and descending, see if there's anything hanging out down at the bottom that shouldn't be there, and that sort of thing, and just kind of helping me look through my data and see what looks unusual. Once you scale this up and start doing bigger and bigger data sets, like it gets very, very complicated. If you're dealing with 60,000 rows, using things like table and unique to see like, what are the unique values of this? Because if it's supposed to be a 1 to 7 scale and you have more than just 1 to 7, if you type in unique, it'll output and tell you like, oh, somebody put in a letter on this, or somebody put 7 period. And so like it'll say 1, 2, 3, 4, 5, 6, 7, 7 period. And so then you're like, okay, I need to fix this. And then, table does the same thing. It just gives you the counts of all the unique things and stuff like that. But a lot of this really just comes down to, playing with things and, checking your structure. For instance, here, so this FT white, FT black, that's like feeling thermometers towards white people and feeling thermometers towards black people. For some reason, FT black is read as a character. So somebody put something in there that is not a number. And so things like that, like when you look at your structure and you check and see like, okay, this makes sense because like, this is the RA thing. And most of my RAs have a number code for when they start the survey, but I always include an other fill-in option so that if somebody has to jump in and cover some sessions, I can still track who was the RA who ran the session. And so in this case, Reagan was not assigned to this study, but she ran some sessions for me. I was able to put that in. So that's a character. And so if I look at unique flag RA, like I can see that like I have some NA values, I have some that are Reagan, but so I could basically recode Reagan to 4, get rid of the NAs, and then convert this to numeric if I was wanting to use that in an analysis or whatever. Oops. Oh, no, that's, sorry. So, okay, yeah. So this is what I'm getting to. All right, so in this data set, 3 of the variables are called C flag 1 through C flag 3. And that was asking people about their feelings towards the Confederate flag and whether it represents heritage or hate and, you know, things like that. So as you can see here, because it was on Sona, or excuse me, yes, Sona, not Qualtrics, which is our participant pool management thing. And so the entire department does their pre-screen on Sona, and then from there we can select. But so instead of exporting just 1 through 9, it exported the labels strongly agree and strongly disagree. And that's why these 3 things are showing up as characters instead of numbers. So one of the things we need to do to clean this up is get rid of all that, which brings us to at least one way of doing that is regular expression. And I know that Patrick linked this website right here, which is the exact same thing that I use. And basically, regular expression is just a way of searching through characters, essentially, and finding patterns. So like this little brackets with capital A through Z, like that means any capitalized letter. This /W means followed by a word, and the plus is a quantifier that says 1 or more of. So in this text down here, it is finding any instance where there is a capital letter followed by a word, which is all of these. If I wanted to change it to where it was any capital letter followed by, say, 3 lowercase letters, you know, I could do it like that, and it will find a capital, any instance where there's a capital letter followed by 3 lowercase letters, you know, blah, blah, blah. And like all this stuff, regular expression is an entire course of its own. But like getting in here and like looking at these references, the different types of character classes and, you know, all this sort of stuff, like you can kind of play with it and just know that this is a tool that if you ever need to find any sort of patterns in characters, that is what regular expression is for. Sub, well, there's several regular expression functions within R. Sub is one of them. And what this is saying is to take the C flag 1 variable and search for the pattern strongly agree and replace it with 9. So when we run that, now you can see that we no longer have instances of strongly agree. Like it's just changed all of those to 9s. Now from there you can expand out, and so we know that we can use this, but instead of like we have 3 columns and we need to replace 2 values, so that would be 6 different sub functions that we'd have to do. So we'd have to say sub for C1 or C flag 1, flag 2, flag 3, each replace strongly disagree and replace strongly agree. So here on line 40, all I'm doing is subsetting and pulling out just those 3 variables. So now I have 3 columns. That's just these 3 things. And then using lapply, I'm saying I want to apply some sort of function across this thing being these 3 columns. So lapply C flag, the function is sub, which is the exact same function that we used above. And the arguments that I want to put in it are pattern strongly disagree, replacement is 1, strongly agree, replacement is 9. And it will run that function with those arguments across each thing. So after I run this line, if we recheck it, you can see that it's now across all of those columns. It has replaced strongly disagree. And run this line, and now all of the things have been replaced, and it's just 1 through 9. But lapply outputs it's a list of lists. So this isn't a data frame currently. It's three separate lists: a list for C flag 1, a list for C flag 2, and a list for C flag 3. And you'll also notice that it's in quotation marks, which means it's still reading it as a character, and we need to make it into integers instead, which is where this comes in. And the only reason I put these extra spaces in here was just to try to make it more readable, because like lapply is what we're going to be using, where same thing, like across this same set here, we're going to do some function, and we specify what that function is, which is one of the weird things about R is when you're trying to convert from characters to integers or numeric, you first have to wrap it in as character and wrap that in as integer or as numeric. And so all I'm saying is go across this list of things here, and for each value, do it as character, and then take that and do it as integer. And then the entire thing I just wrapped in data frame so that it'll output a data frame. And now when we check that, like now they are all numeric as a data frame. That's, we talked briefly last semester about user-defined functions, and that's all it is. By saying like function X, I mean, you could put whatever you want. You could call this, function whatever, and then over here you would just say whatever. And basically that's just saying a user-defined function is whatever goes in here gets put in over here. So in this case, what it goes in here is each one of these values across this list. So it just takes each thing and plugs it in here, which moves it over here and does whatever computations or transformations and blah, 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 all that sort of stuff that you're doing. So, and then from here we have, our C flag data set, and all I'm doing is storing that over the flag C data set. And now when we check our structure of those three variables, we correctly have integers instead of characters. Yeah, in this particular case, I am. It depends on what type of data cleaning it is, as to like, because sometimes I won't save over variables. In this particular case, like I'm not changing the variable, like I'm just stripping the characters away from it, which is another approach that you could take. Instead of saying search for strongly agree, you could say if the label was like 1 strongly agree or 9 strongly disagree, you could say match the first character in each of these strings. Then for all the ones that only have a number, that number is the only character. It is the first character. And then on the ones that have a number and then some sort of text label, like that first character would be the number. And so if you just say extract the first, character of each of these strings, you wouldn't have to worry about the text part. It'll just cut all that off. So there are an infinite number of ways to approach any of these things, which is why this is a very long, and like you just have to look at your data and think, okay, what do I need to do here? And then figure out the specific solution for that. We're also briefly going to talk about gather here. Although, like literally just, if it wasn't last week, then it had to have been like right at the end of the week before. But there was actually, I realized through one of the R blogs that I keep up with, that Hadley Wickham himself was talking about how gather and spread are going the way of the buffalo as functions. Not in the sense that they're going to be depreciated and removed from the package, like they'll still work, but they're giving way to what's called pivots. And so I wanted to throw that out there to let you know that, like, I mean, they already said, like, they're not removing gather and spread from the libraries, but they are working on a better way of doing it using this pivot. And so instead of using gather, there's a function that's like pivot long. And what that's saying is take this data set and pivot it into long format. And the specific arguments that they use, instead of using key and value, I'm trying to remember, like they changed like what these variables are called, because gather and spread, I think, in my opinion, is probably one of the most divisive, or two of the most divisive functions in the tidyverse. Like people who love tidyverse, a lot of them still hate gather and spread specifically. And I was one of those, and I still hate spread, and I don't ever use spread because, I mean, the data is probably already in spread form anyway. Like, I have a hard time imagining that you're going to have a data set that comes in long form. So if you just need to spread it, like that's just your original data set. If ever the time comes and you need to spread something and can't figure it out, hit me up and I'll be happy to help you figure it out. But it's something that I will literally have to figure it out because spread just doesn't make sense to me. But gather, a lot of people don't like this. And there's another package called Reshape2 that has like the same things, but instead of called gather, it's called melt, and you're melting your thing into a long thing, but that's neither here nor there. Point is that, like, especially with this key and value as arguments, like a lot of people don't have like an intuitive understanding about what that means. And so basically, here all I'm doing is I'm subsetting the data frame to make it a little more manageable. So we have sub ID, C flag 1 through 3, their overall political orientation, and what condition they were in. And we'll just say, for example, that C flag 1, 2, and 3 are actually like 3 different time point measurements of some single DB, rather than saying these are 3 questions that make up 1 DB. So with gather, think of key as meaning like, what do you want to name the variable that you're collapsing these things across? What we want to do is we want all 3 time points to be in 1 column. Well, really 2 columns, because we need 1 to specify whether it's time 1, time 2, time 3, and then we need a column that is the actual value of that time. So each participant should have 3 rows. One that, like, one cell says C flag 1, value 3. The next row should be C flag 2, value 5. C flag 3, value 4. So key is just what do you want to name the column that specifies what the variables are. In other words, the column that will say C flag 1, C flag 2, C flag 3 as what's in the cells. That's your key. Your value is what do you want to label the column that has the actual values in it. So when we run this line, you can see that what it's done is it's collapsed. Let me also specify. So first you put in like what the data frame is that you want to gather, what your key and your value is, and again, that's just what do you want to label these things. And then over there it said C flag 1 through C flag 3, and that's telling it what cells you want to collapse into whatever this key variable is. Things that also work for this is you can use like a minus whatever if you're wanting to exclude a variable. So let's just say if we don't have these 2 variables right here, and we only have like sub ID and C flag 1 through C flag 3. Instead of saying C flag 1 through C flag 3 are the variables we want to collapse, we could just say not sub ID. Collapse everything else, but not sub ID by putting minus sub ID, and it would do the same thing. Because we have all these other variables, we could say not sub ID, not political, or not overall PO, and not condition. But in this particular case, it's easier just to say collapse C flag 1 through C flag 3, and that's this one up here that's kind of hanging off the edge of the screen. So again, gather your data frame, your key, which is what you want to call the column that has the variables in it, and then your value, which is what you want to call your actual value column output, and then which variables you're wanting to collapse or not. And then this, I'm just demonstrating that again, like key is just what do you want to call the variable column. And this is the value is what do you want to call that value column. And if we look at that whole thing, now you can see that each participant has three rows. First participant, C flag 1, C flag 2, C flag 3, and then program he puts in them. All right, do y'all have any questions over that? All right, well then let's just go ahead and work down through these portions down here where we're filtering things, creating some variables. I might suggest starting a little bit lower down here, specifically like with ideology and transforming with gather, and working on knocking those two out first. These other ones are all just reiterating stuff that we've done literally all year, like, hey, filter out these specific things. And right here, like, break down condition based on this or that. And so that should be nothing new. But these two down here are more new. And so work by yourself, with a group, with a partner, whatever. If you have questions, I'm here. And we'll go from there. Select is for subsetting. So select is selecting specific columns from the data set. Filter is filtering out certain rows. So when you're using filter, you're saying, you say filter whatever your data set is, and then whatever the passing criteria is. So if you say that age has to be over 18, it'd be filter DF age greater than 18. One of the nice things about the filter function, as opposed to using like the base R method, where you're using like the bracket notation, is that with that you would have to say like age is greater. If you have multiple filter criteria, it's age is greater than 18 and whatever is whatever and. But with filter, like, it's just commas in between each argument. So if you have 5 different criteria that you want to match by, they have to be at least 18. They have to be white. They have to be born and raised in the South. Then it's literally just like age is greater than 18, comma, race equals 6, comma, Southern equals yes, close parentheses, and it will only output things that match all of those criteria. Answer your question? And then for select, that would be selecting the column. So you're saying select, I want, the ID column, I want the condition column, the DV column, this, and this. And now it outputs only those 6 columns in your data frame. So you can think of it as select reduces the number of columns and filter reduces the number of rows. Yes. I don't know. No. Yeah, I don't have a clue. And I mean it shouldn't be